This is a video about the UCSD TA application, and I will give a question. Given two integral arrays in order sequence and post-order sequence, in order sequence is an in-order traversal of binary tree, and post-order sequence is a post-order traversal of the same tree. So please construct the binary tree. Let's start with review how to write the in-order sequence and the post-order sequence. I give a simple binary tree. And to write the in-order sequence, we tend to first write the left subtree, and then the middle part, and then the right subtree. And for the post-order sequence, we tend to write the left subtree and the right subtree followed by the left subtree, and at last we write the middle part. So in this simple tree, we can for the in-order sequence, we first write 9 and then 3, and then we meet with the right subtree, and it's also a binary tree, so we first write 15 and then 20 and then 7. So the in-order sequence gives us 9, 3, 15, 27. And for the post-order sequence, we first write 9 and then we meet with the right subtree, and we first write 15 and then 7, and last we write 20. After write all of the whole subtree connected to the node 3, we then write the node 3. So the post-order sequence gives us 9, 15, 7, 23. And the description of the tree restoration progress. First, we need to find the root node in the post-order traversal sequence, because the post-order sequence, we always write the root node at the end of the post-order sequence. So we first need to find out the root node in the post-order sequence, right? And based on the root node, we need to find the position of the root node in the in-order traversal sequence. According to the position of the root node in the in-order sequence, and then we can divide the in-order traversal sequence into the left subtree and the right subtrees, and determine the boundary position of the left subtree and the right subtrees in the two traversal sequence. If we find the root node in the in-order sequence, we can know the 9 is in the left subtree and the 15, 27 is in the right subtree. And we can find the boundary of the two subtree in the post-order sequence, and 9, and then it is 15, 7, 20, and we can do the same work recursively to construct the two subtrees, left and right. So this is the description of the tree restoration process. And then we need to restore the tree and combine with the in-order sequence and the post-order sequence. So we first find the last node in the post-order sequence is 1, and then we find the position of 1 in the in-order sequence, and then we separate it into two subtree: 4, 2, 8, 5, 9, and 6, 10, 7, 3, 7. And we do the same job recursively for the left subtree and the right subtree. So for the left subtree, the sequence gives us 4, 2, 8, 5, 9. This is the in-order sequence, and this is the post-order sequence: 4, 8, 9, 5, 2. And we doing the recursively, we need to find the last node in the post-order sequence is 2, and we combine this node 2, we can separate the subtree into two parts. One is a single node and another is a sequence. So the 4 is the only single node for the left subtree connected to the 2, and the sequence is the right subtree connected to the node 2. And we can combine with this block, and we know the 8 is for the is the left subtree connected to the 5, and 9 is the right subtree connected to the 5. So we construct the left subtree connected to the 1, and then we start to figure out the right subtree connected to the 1. Combined with the two sequence in this block, this is the in-order sequence 6, 10, 7, 3, 7, and the post-order sequence 10, 6, 7, 3. And we also always need to find the last node in the post-order sequence is 3. And combined with the 3, we find the position of 3 in the in-order traversal sequence. And then we separate the subtree into two parts. One is 6, 10, and another is the 7. So we know the subtree, right subtree connected to the 3 is only have a single node is 7. And then we turn this block. This is the left subtree connected to the 3. And we also always need to find the last node 6, and then we find the position of the 6 in the in-order sequence, and then we know that the right subtree is only a single node 10. So we finally build a whole subtree through this way.